Olá, pessoal, tudo bem? Sejam bem-vindos a mais essa live aqui no canal da Emerging Code. Agora, no ano de 2021, essa é a nossa primeira live aqui. Essa live vai ser uma live em inglês, onde eu vou apresentar o Dejan, tá? Eu inicialmente introduzo as lives em português para as pessoas que estão no Brasil, tá? Essa live a gente vai falar sobre Machine Learning, RavenDB, como é que a gente consegue fazer toda essa mágica acontecer dentro do RavenDB, que é um banco bem conhecido aí na comunidade e desenvolvido pelo time da RavenDB, ok? Vou trocar aqui de idioma. I will switch to the language. So it is a pleasure for having Dejan here in the Emerging Code channel. So Dejan is a director of engineer at Shift. Correct me if I'm wrong. Yeah, and he also support the RavenDB team with some features, developing something there. So, and Dejan, in this live, we will show to our audience how they can build machine learning features and use this cutting edge technology on top of the RavenDB, right? So
yes,
the stage is yours, and please introduce yourself to our audience.
thank you. My name is Dejan. I have been developer for over 20 years. I studied computer science. I was interested in compilers. My graduation thesis was on compilers. And then I proceeded typical life path of a developer. I was working in various companies. I was participating in open source projects. And at the moment, I'm working for a Shift startup from San Francisco. I was using relational databases until recently, some 5 or 6 years ago. I was starting to watch tutorials on NoSQL databases. I was reading Oren's blog. And I was generally aware what NoSQL databases are. But as most developers, I was thinking, okay, this technology was developed for big companies like Google or Facebook. They are operating with big data. And for my hobby projects, I'm using these small databases. So why would I use NoSQL databases? So I was aware of RavenDB, that RavenDB is a great piece of technology, but I just did not see where it can be used in my case. And then over time, I learned that RavenDB is not only good for big projects, for large amount of data, for terabytes of data. RavenDB is also good for small hobby projects. And the whole point here is that even today, some 10 years or 15 years after first NoSQL databases emerged, developers are still not completely aware what NoSQL databases are and why they can be good. And it's not only about processing large amount of data. It's not only about speed. It's also about modeling. And if you're doing domain-driven design, for example, then you will find natural match in NoSQL databases, because when you read domain-driven design and when you stumble upon a notion of aggregate, then later on you realize that aggregates are literally equal documents in RavenDB. So this evening, because I'm living in the part of I'm living in Europe, it's winter here. So this evening I will try to show you some unusual things. So how can your database can support machine learning and various different applications of database extensions. So I would like first to speak about one interesting feature of RavenDB, which is main computation leverage of most NoSQL databases. Let me create one empty database. And as you can see, I'm running this on my machine. I will seed some sample data so we have something to work with. And this is small e-commerce database. This is Northwind. Northwind is a canonical example Microsoft has been serving with SQL Server and Access for a number of years. And in this case, what is interesting here is that this was imported from relational databases, and data was remodeled into document model. And as I said, if you take a look at this, what you can see here is aggregate from domain-driven design. So you're looking at one entity, which is aggregate, and what you can see here is the example of value object. So value objects do not have meaningful existence outside of the boundaries of the aggregate. So in this case, this is order line. So if you take this order line out of the order, it does not make too much sense. What I wanted to talk about is the notion of Mapreduce indexes. So Mapreduce indexes are the common feature that enables NoSQL databases to query data and to give you results. What join is for relational databases, Mapreduce and map is for NoSQL databases. So you can see one example of map index without reduction here. And for some of you that may face the notion of Mapreduce for the first time, I was thinking a lot how to represent what Mapreduce is. And I think I managed to find a good example. So Mapreduce emerged in big companies like Google and Facebook where they process large amount of data. Mapreduce is a tool for distributed processing of large amount of data. So if you imagine that you have a skyscraper like this, and you would like to count the number of people living in this skyscraper, if you would apply standard principle and you imagine yourself as one computer, then in order to process this skyscraper, you would have to go floor by floor and knock on the door by door and ask people, how many of you live in this apartment? So this would be single-threaded way to count inhabitants of this skyscraper. Mapreduce would be equivalent of you gathering a lot of people, your friends, and your friends represent additional machines in this example. And if we imagine this as 20-story skyscraper, you would gather 19 of your friends, and you would go, and every one of you would process one floor of this skyscraper. So you would enter first floor, your friend would enter second floor, and then you would go door by door and ask people, okay, how many of you live in this apartment? In the end, you would gather again on the ground floor, and every single one of you would have the number of the inhabitants living on a specific floor. And then what you would do, you would simply sum these numbers and you would get a number of people living in the skyscraper. So that's what Mapreduce is about. It's about distribution of tasks and processing things in parallel. And this is the way to speed things up, to speed up processing of data. And this is something that, for example, Google is using to process large amount of data, which would be very, very slow otherwise. And this same mechanism is used inside of RavenDB. So for example, if we take a look at the orders you can see here, you will see that these orders have order lines, but you don't have a total sum of the order defined anywhere as a property. So with Mapreduce, you can write index that looks like this. And this index has a map phase, which will take one by one order. And then it will count the total by summing up all of the order lines. And this is something that can be executed in parallel. So if you have 5 million orders, there wouldn't be 5 million times one processing like this. There would be many parallel operations executing across your database. And then when this indexing completes, what you have is the sum up of total value of all orders in your database. And then you can go and ask, okay, I would like order with this total, or you can go and do something like this. I would like all orders with total amount greater than this. And what is interesting here is this query executes against pre-computed data. So as you saw here, if I go into order totals here, into index terms, you can see that all order totals have been pre-computed. And this is very important because it is enabling you to execute fast queries against your data. If you don't have something like this, this means that every time you execute query which has some kind of filtering, your computation will be done during that query time. Okay, and let me show you one typical example of aggregation that is done with RavenDB. So as you saw, I'm having my orders here. And if you take a look, this order contains some products. So now I can use Mapreduce to implement one non-trivial feature, which is product recommendation. And product recommendation is, in its essence, is very simple thing. You will observe all orders and you will count times products are appearing together. So for example, if I go to the beach, if I buy a towel, I will probably buy a sunscreen. But my website, my e-commerce website can recommend something like that to me. So in RavenDB, you can write Mapreduce indexes that will pre-compute data for you. So what I will create is this Mapreduce index that's doing product recommendations. So this is so-called mapping phase. And I'm going over all orders and their order lines. And for every product, I'm taking all other products from this same order and I'm counting one. So I will count one for every product that appeared together in the same order with my product. Then I need to do aggregation. So I need to do some summing up, and I will use my product as the aggregation key. Now when I save my index, as you can see, my index processed all of the orders in my database. And what I can do now, I can go and query my database for the recommendations on the products. And I prepare this ahead of time because it's more fun to watch results than watch me typing. So here I'm querying my data by the means of this index. And I'm getting product recommendations here. So for example, if I open this camembert cheese, I suppose this is camembert cheese. What you can see here is the sorted list of the products that were both most frequently with my cheese, as you can see. And this is non-trivial operation because I'm going over all orders. I'm counting how many times product appeared in the order, and I'm coming up with the result. So this is non-trivial. And as you can see, if I turn the caching off,
it is a very cost. This cost is very expensive, even, you know.
Yes.
If you decided to go on this path, you will do your application pay back the performance for the users. Yeah.
Yes, and usually if you map mentally this same implementation in relational database, you will remember that we all developers had numerous cases of our code executing quickly on our machines, and then when we deploy application to the production conditions and our web application is live, over time amount of data grows and grows and grows, and our application is slowly becoming slower, and then our visitors are becoming dissatisfied and our clients becoming dissatisfied. So speed is very important. If I remember correctly, Yahoo did some measurements, and they were intentionally adding tens and hundreds of milliseconds to their web pages, and they were able to measure a drop in conversion rate. So it's not just a fairy tale. When your e-commerce website gets slower, then it will reflect in the way that some of your visitors may give up whole checkout process before spending money at your website.
Yeah.
And what I have here is the typical example of developer developing e-commerce website. I seeded some orders here. I have 830 orders, and I completed the development of this, and I measure performance, and my query is executing fast. So you can see execution time here, and if you observe, it's executing very fast. So I did my job. So what will happen now if I have hundreds of thousands of these orders in my database? What will be effect? So let's simulate that. I will perform patching operation, but before that, I will turn off document revisions for the orders to make things faster. So what I will do now, I will simulate that some time passed, for example, 1 year passed, and my website grew from 830 orders into 83,000 orders, because I will take every order I have now and I will create 100 copies of my order. So I'm now simulating people going to my website and buying things. So what you can see now is that I have 83,000 orders. So now let's see how my query will behave again without caching. So these are row results coming from the database. So if you observe here, and we had something like 20 to 30 milliseconds, we are having approximately the same results, which is a bit strange because that's not something that you would expect. So let's multiply that a bit more. Let's increase that to about 1 million orders. And as you can see, this is now proceeding. If you take a look at the server, you will see that I'm hammering my server, which is running on my developer laptop. And you can see I'm generating around 10,000 write operations per second. But this is nothing dramatic for RavenDB. So while I'm hammering my database, I can still go and issue queries. So my queries are not blocked. And you can see that I'm hammering, really, I'm DDoSing my database, and I'm still able to execute my queries in a non-blocking manner, as you can see. And the caching is off. So this multiplication is now proceeding, and soon we will have around 1 million orders in our database. So now I'm checking what will happen if e-commerce website becomes really popular, if lots of people arrive, lots of customers, if they order a lot of things, how my website will behave in that case. And by the way, load balancing is something that lots of developers are not doing, but it's very, very important because it can help you predict what will happen with your website. And every time you hear about Black Friday and websites not being able to serve all the visitors, you can be sure that load testing, was not done in a proper fashion. So my multiplication is now over. I have slightly over 1 million orders in my database. And again, going to my query, when I execute it, you can see that query times did not change. So even if this website becomes really, really popular, owner of the website will be really satisfied because amount of data will not affect the speed of his website. And what magic lies behind this is Mapreduce. So let me show you what really happens behind. This is a visualizer of Mapreduce that's built into RavenDB. And this is how typical Mapreduce operation proceeds. So you remember I gave example of the skyscraper and operators going on every floor of this skyscraper counting people. So similar things happens here. Here at the bottom, you can see orders. Here is the partial aggregation. And as you can see here, appearances of other products with this product are counted here. You can see the partial aggregation sum here. What you can see here, what you can read is that there's 94 more partial aggregations. And then on the next level, these 95 partial aggregations are summed into the total amount. So interesting thing here is when new order arrives to the system, our index will catch it up. It will count additional products that appeared in this new order. But very important thing is that when you need to update, when you need to perform update on this Mapreduce index, it's very cheap because engine will update values just in two places. Let's imagine we added one more order here containing this product. Update will be done in this partial aggregation, and this total aggregation will be updated, and that's it. So we have 1 million orders in our database, and when new order comes, we need to do, or RavenDB needs to do update just in two places. So this means that updates to this Mapreduce index are cheap, and we are not sacrificing anything because our queries are fast as well. And in RavenDB, when you query data, you always query pre-computed data. That's why results can be this fast. By the way, if there are any questions, I would be also glad to answer them during the presentation. Okay, and you might ask yourself, the title of this talk is Machine Learning. I'm not there yet, but what I'm showing you is supporting mechanism behind ability to add machine learning. So let me show you something interesting. I have one database prepared here, and this is database that was obtained, that was populated by the publicly exposed data set. So over the internet, you have these big data sets that are publicly exposed. In this case, what you can see here is that City of Chicago has data portal, and they are exposing publicly available data on taxi rides in this case. So when you need to do any kind of processing of your data, you can go and from a website like this one, you can pick up some sample data and start experimenting with it. So what I did here is that I imported taxi rides into this database, and I'm using a very interesting feature of RavenDB, which is called time series. So if we take a look at this taxi, and you can see this is anonymized data. Under time series, you can see that I imported over 5,000 rides for this taxi. And each one of these data points represent points of time. And on this location, this taxi either did pickup or drop off. And as you can see, there are thousands and thousands of values here, namely 5,000 recorded rides for this taxi. And we have over 9,000 taxis here. So this database at this moment in time contains over 50 million data points. Again, which is non-trivial. And I would like to show you some kind of possibilities of RavenDB to execute non-trivial queries. So what I was interested in this case is to do some kind of analysis of my data on taxi rides. So what we can do to a website like this, and we can make a drawing of a polygon of a specific location on the geographic map. And what I can show you here is the part of the city of Chicago. So what you can see here are the coordinates in this WKT format. And you can freely drive these points around and draw any geographical area that you would like. So idea here is to do analysis of your data and to figure out which taxis entered this original area during a specific period of time. And this is interesting because we live in times of pandemics. So for example, things like this can be used for analysis of anonymized people moving around. And let's say we would like to examine how many people entered or exited this area. And again, this is something that's non-trivial. So with RavenDB, I can go and do something like this. I can issue a query that's very interesting. So what I'm doing here, and I will show you implementation of this in a moment, but I'm doing analysis of the taxi movements across the time and space. So what you can see here is that I'm querying December 1st of 2019, looking for all coordinates of the taxi pickup or drop-offs within this region that I showed you a moment ago. And remember, I'm having over 50 million data points. And this query is non-trivial. I'm looking for all taxis that entered or exited this specific geographic area on December 1st. So now if I execute this, if I turn off the caching, if you take a look at the result time of my non-cached query, you can see that I'm getting really fast execution times. So I'm able to analyze over 50 million data points in less than 20 milliseconds and figure out that I ordered by the count of the vehicles that entered or exited this area. So I'm able to deduct that on December 1st, 2019, 2 a.m. GMT, 43 of vehicles entered or exited this geographic area. And if you think about it, this is probably like, because it's Chicago, so I would say this is 8 p.m. on Halloween evening in Chicago.
It's a very impressive performance that RavenDB has been getting during of these years. So it's awesome to see how RavenDB is delivering this high performance, running this kind of query over 100 million rows inside of this database.
Yes, and now we are getting towards machine learning slowly, but we will eventually get there. So what I'm showing here is the definition of the index so this is whole implementation. And this, what you're looking now, code on my screen that you're observing now, it's enabling me to query over 50 million data points in 20 milliseconds. So I won't go into too much technical details, but there's one very interesting thing here, and it is this line. Here, I'm applying geohashing to compute location. And for you who don't know what geohashing is, so it's this technique where you divide surface of the Earth into the grid, into the squares, and then you divide squares again, and then you proceed with this division. So with a precision of 9 places, you have a precision of a couple of meters.
It's a kind of segmentation, right? It's RavenDB using the geohash algorithm. It will segment the data in chunks, right?
Yes.
Like below chunks. And when you apply that technique in the SQL statement, you are running that query on these chunks, right?
Yes.
Okay.
So I managed to find example here, so you can see you divide whole surface of the planet Earth into rectangles like this one. Then you take every rectangle and divide it again, and then you proceed. So this is precision 4. And then if you take one rectangle like this, divide it into segments again, and proceed with each segment again, and on, you will reach level 9 of this division. So I think there's interactive map here. So as you can see, whole world is divided into these rectangles. And then these rectangles are divided again, as you can see. So the more you divide these rectangles, the more precision of location you will get. So that way you are able to give 9 letter and numbers to someone and to be able to determine your location with high precision, as you can see. And this feature, now we come to the point that this feature is not supported by RavenDB. So geohashing and coding that you can observe being used here is not supported within RavenDB. But RavenDB has a very interesting feature, which is called additional sources, that is enabling me or any other developer to provide additional functionality to RavenDB in the form of either C# code or JavaScript code. This way, you can extend features of your database, and you're limited only by your imagination. So any kind of code can be supplied here. So as you can see here, I have this encode method that is accepting coordinates and returning this geohash code.
It's very interesting. because seeing this implementation, I can understand that this class and this method will be transliterated to be used in the SQL statement. So if you see in your SQL statement, Geohash is a class and code is a method, but they came from the C# implementation. So the
Yes.
RavenDB understand and transliterate the C# implementation into the function that can be called in the SQL statement, right? It's not a SQL statement, it's RQL, RavenDB query language.
Yes.
So, yeah.
Yes. So in this case, geohashing encode is defined in this class as a static method. It's called here. And then if you take a look at the index terms, you will see that I'm having my taxes here and coordinates being encoded as geohashing. So these geohash codes are the results of executing this C# method that I provided here as an additional source of computation for RavenDB. So this way, you can extend functionality of your database, which then again means that more computation will be handled by your database, and your database will pre-compute your data ahead of time. So then when you do queries like I did, I will get my results in milliseconds, even if I have 50 or 100 million data points. And if you think about it, the only way you can get millisecond range of querying time against data is to pre-compute results ahead of time. So computation is done once, results are stored, and then when you ask for result, you get results immediately. So that's I wouldn't call it secret of being fast, but that's the secret sauce that can enable your application to remain fast even when amount of data is increasing over time. Okay, so those were taxes. I have one more database to show you. One more example now, if we proceed along this way. There are other things that you can do. There are other functionalities, as I said, you are only limited by your imagination of the things that you can do. So what I have here is, again, this same database. And if you take a look at the employees that I have here, I have 9 employees here. There's interesting notions of attachments for documents in RavenDB. So you have JSON document here. As I said, if you're doing domain-driven design, this is an example of the aggregate. And as you can see, various nested, complicated data structures can be stored here, and then later on queried via indexes. Interesting thing is that RavenDB supports notion of attachments, and this is very similar to email attachments. And you think more about it, what is more natural place than store additional information about your documents than in the database itself? So with relational databases, you have this binary large object columns, which are increasing the size of your documents. With RavenDB, you have concept of attachments where you have binary files related to the document but separated and isolated from the document itself. Attachments are stored in the same location where database is, but they will not increase the size of the document itself. And what I prepared here is I created biography of Laura Callahan, short biography here, as you can see. I can increase it a bit. So I imagine that Laura Callahan likes long walks in nature, flowers, and Netflix. And then I exported this as a Word document. I saved it and I attached it here. So as you are probably aware, RavenDB supports full text search functionality because RavenDB is built on top of Lucene.net. And every single functionality of Lucene.net is available in RavenDB. So if you take a look at this employee, there's free text note here, and you can see that I have various terms here, and I have French as a language that Laura Callahan is using. With RavenDB, in order to perform full text search, I don't need any additional solution for full text search. I can go and do a query like this right away. So what I did here, I have 9 employees. I filtered those employees that have word French in their notes. And this is great because full text search is something that almost every business application needs. And sometimes this need will emerge after some time. So you need to find a solution. And most of the developers I'm speaking with will go and use Elasticsearch. So if you're using SQL Server and you need full text search with all these various term boosting, highlighting, etc., you will go for Elasticsearch. So you will install cluster with elk stack, and then you will implement API that's searching Elasticsearch, returning results on your web application, and so on. With RavenDB, you have full text search capability out of the box. But then if you take a look at Laura, I was searching against this, but Laura has some additional info here. And unfortunately, I would like to search, for example, and see, okay, her birthday is coming. Her birthday is approaching. I would like to give her a present. And I'm working for the HR. So maybe if Laura is watching Netflix, I could give her a present of Netflix subscription. But then I need to go open this document and see what Laura needs to do. In this case, I can also provide full text search against any attached documents. So what I have here is the Microsoft Word .x document, and I can index its content as well. So what I did, I prepared this index. And this index is very simple, as you can see. So I'm going over all employees. I'm accessing their attachments, and I'm filtering Word documents and filtering Excel documents. And then I'm extracting text from Word documents and indexing that, and I'm extracting text from Excel spreadsheet and indexing that. And of course, RavenDB does not support this feature either. And I used additional sources one more time. So what you can see here is that, again, I used very simple code that is extracting content of the Word documents and of the Excel documents. So this method is extracting text from Excel documents. This method is extracting text from Word documents. And here I'm creating new field that's called documents that will contain the content of this file that is attached, which you can see here. And now if I go into index terms, what you can see here is that RavenDB picked up attachment and extracted text and then did full text indexing against these values. So if you take a look at the employee search index, what you can see here is that I additionally defined this documents field to support full text search. So now I'm able to do something like this. Let me see which of my employees are watching Netflix. And as you can see, in this case, I only have one biography as an example. But if every employee in my company had biography, I would be able to do full text search against the content of their biographies.
It's very interesting because sometimes we can avoid the user send some kind of file extensions through by our application to the server. But in this case, we can add the double check inside of the RavenDB, filtering the kind of the different kind of the extensions, right?
Yes. Yes. And now when you mentioned that, next example I would like to show is related to what you just mentioned. Analysis of the text itself. And now here comes the machine learning that was we were waiting this whole time. So machine learning is a very, very interesting area. And I learned about it at the university, but I never really used it in real life because, again, same with NoSQL databases, I couldn't think of the application. Okay, I was playing around with it, but I couldn't think of realistic use case, a real life scenario where I could use machine learning. And what is good thing is that Microsoft entered area of machine learning, and you have very nice examples created by Microsoft. Microsoft entered this area a bit late, and you all probably heard about TensorFlow and people using Python. But now .NET ecosystem is catching up, and you have all these nice examples of machine learning being used on realistic examples. So this same product recommendation feature that I implemented a moment ago can also be implemented by using product recommendation, machine learning product recommendation, or taxes I showed a moment ago. You can use machine learning to feed examples of taxi ride with prices, and then use machine learning to try to predict price of the taxi ride. You can also use various interesting things and techniques like fraud detection, which is very important if you're working with credit cards or money. You can do object detections, so you can recognize objects on the videos or images. You can do various ways of image classifications, sales forecasting, customer segmentation, which are all real life examples. And Microsoft usually goes and provides very good support for developers. So you have machine learning samples here. And what I did for this example, I decided to analyze tweets and categorize them. So what I did again, I went to this Kaggle website, and Kaggle is very interesting because when you start doing machine learning, you will visit this website very often because they collected some examples of sample data that you can use to train your machine learning algorithms, machine learning models, and then to use those models for real life examples. So what I did, I took this comma-separated database on tweets, and these are the tweets about US air companies. So various things people are tweeting about airlines. And you can imagine if you're waiting for a plane and plane is late and you're young and impatient, you will tweet something bad about air company. So what I did, I created a new database here, and what I did, I imported these 14,000 tweets about air companies. So if I open one such tweet, you can see this is what is important here. So various tweets coming from people using various air companies. So as you can see, you can imagine there's lots of various comments here. So how can I use RavenDB to recognize tweets that are speaking bad about my company? Because that's what I need to do. It's nice when customer taps you on the shoulder and when customer says, I had great experience. That's what you expect. But what you really want to do is to observe when your customers are not satisfied and to react to that. So machine learning is about programming unprogrammable. So these are problems that are very hard to program. And classical programming that we developers do is that we give instructions to machine. So when you see this, when you detect this, do that. Machine learning has different approach. It's about the same approach as if you have a small child. You will try to teach your child by example. And same thing goes with machine learning. So with machine learning, you will do something like this. So this is how you train your model. So you take all these sample tweets. So you select subset of your data and you designate this as a training set of your data. And then what they are doing here, what is this example? Someone inspected, read all these texts and marked ones with number 1, which are toxic. So this is analysis, human analysis on toxicity of these tweets. So for example, if you take a look at something like this is toxic tweet, and it is marked here. So you try to explain to machine which of these texts are toxic and which are not. So when they are toxic, you put number 1 here, so this represents true. And for example, this is quite neutral tweet, so you mark this with 0. So this is training sample. And then you will find examples in this repository how you can train your machine learning model. When you do it, you will get zip archive, which contains trained model that is able with certain probability to detect toxic tweets, toxic texts. So what I did here, I created again map index. And as you can see, the further we go with these examples, the simpler these codes are, because I'm outsourcing more and more functionality here. So what you can see here, this is additional source, and I have it here. This is code that is doing sentiment analysis of my tweets. So this is the code, and what I did, I took a zip file with the model and I uploaded it to RavenDB. Then I wrote code that's very simple, basically. So you can see I'm referencing path to zip model that's called sentiment model. And I'm simply doing something like this. I'm initializing machine learning model with engine with this model. And I'm simply asking my engine to predict the sentiment of the text I pass. So as you can see here, is actually one line that is calling my machine learning model engine for prediction. And then if this is true, tweet is toxic, and I'm returning tag toxic, otherwise is non-toxic. And then I'm returning score that represents probability. Because with machine learning, you don't ever have binary results. It's not 0 or 1, true or false. Machine learning gives you probability percentage what it thinks is true. What is also interesting here is you can see I'm using Microsoft.ml, Microsoft.ml.data. So where these namespaces are coming from. RavenDB 5.2 contains this additional assemblies feature where you are able to supply NuGet package to RavenDB. So it's not just the source code anymore. Now you can go and refer package by the name and by the version number. So if I don't have this NuGet package, I will get an error because my additional source will not know where to find these namespaces. But in this case, I supplied a reference to NuGet package Microsoft.ml. So now this code will analyze all these tweets in my database, and it will produce characterization of these tweets. And what is also interesting is that I will create so-called dynamic field. So if I go into index terms, you can see I indexed all the tweets by the airline. So I'm able to select tweets talking about American Airlines. But I'm also able to see non-toxicity characteristics predictions and toxicity predictions. So for example, this is something that's quite neutral, as you can see. So machine learning gave me here 50% chance. If you take a look at this, this is 0.5, which you can read as 50% chance that this tweet is toxic. And we have pretty good guess here because this tweet is quite neutral. So you could say that everything that's around 0.5, it's neutral. But now if I go, let's see what machine learning engine thinks that is over 80% toxic. If I open something like this, you can see Virgin America, you suck. So this is what we have here is the machine learning model detection of toxic tweets that Virgin America needs to pay attention to. And then if I increase this, you can see that amount of tweets that are filtered is getting really, really low. So what we have here now is 14 tweets where we have 99% chance that tweet is toxic. So you can see this is very, very toxic. So this was a customer that was very furious with this company. So this way, now I can, as new tweets arrive into my system, as new tweets are being inserted into my database, I can analyze and pick up those with negativity and react to them. So this is not a job for a human anymore. This is something that machine can do for me. Okay, and analysis of the text is something that's that is natural to us. So we can understand that machines are processing text and doing various things with text. But what is really impressive for me is the ability of machine to analyze images. And this is second example of the machine learning today. So what I wanted to do in this example is to go back to my employees and analyze their photos. So as you can see, every employee here has attached photo, every single one. So I wanted to analyze if my employees are happy or sad or dissatisfied or satisfied. And this is something that, okay, as I said, recognizes certain words in a text. May not seem complicated, but analysis of the images sounds very, very complicated and a bit scary. And again, I used these machine learning samples. So what you can see here is the machine learning library based on TensorFlow. And this is, again, Microsoft sample of machine learning. What they did here is they took a set of training images of the flowers. They labeled these flowers with the names of the flowers. And then they trained machine learning model against these examples. So this data set will be used to teach machine learning model how to recognize flowers. And this is a very nice example, except for the fact that I don't have flowers. I have human photos. So what I did, I found something like this. So this is very interesting. This is the world's largest emotion database, where you have people spontaneously gathering data and accepting to share their images with the rest of the world. And most of these people in this database are driving, which is very good because when you drive, you get lots of emotions. Since training on 5.3 million faces would take some time, I found a bit smaller data set. So I found this article, which was published recently, and it's very nice. Here, machine learning is applied to human faces to detect human emotions. And I used sample data set from this article to train my model. So how you train your model with images? Very simple. You create folders, and folder names will be used as labels for human emotions. And then within that folder, you will supply images that are representing people with those emotions. So for example, if you take a look at this is someone who's obviously angry. Or this one, for example, again, someone who is angry. And you can see that these images are rather small. They are black and white. They are cleaned of any noise. And this is also important. The better data training set you supply to your machine learning, the better results will be. So then again, I took this training data set, I applied it to Microsoft example with flowers, and I trained my model. And then I wrote index that looks like this. So for all of my employees, I'm loading attachment, and I use the name photo JPJ, but of course you could take all the photos, all the attachments with PNG or JPJ or GIF. And I'm calling image classifier to get results of classification of the images. And again, here is additional sources, which is not too complicated. which is simply reading stream that represents my image, using image classifier trained model, which I supplied to RavenDB, and it's producing qualification of my images. And as you can see, I had to add references to 4 NuGet packages in order for RavenDB to be able to take this, compile it, and use it within the index. So as you can see, I can supply here DLL on a specific path. I can specify a reference to a NuGet package, so I'm unlimited by my imagination. I can also take OCR code and extract text from images. Okay, so now if I go into index terms, you can see that I managed to label my employees with the tags, and I'm able to do search on my employees which are calm. And because I had a rather limited training set, and since images in this sample database are rather generic stock photos, I'm getting here that my machine learning recognized that all of my employees are calm. So this way, you can use your database to perform various analysis and to come up with various creative scenarios for querying your data and to build additional functionality on top of this. Okay.
Okay.
Any questions?
So, guys on the chat, if you have any questions, send us your questions, and yeah, Dejan will try to answer. Feel free.
Okay, so important thing to mention is that this is just part of things that your database can help you with. RavenDB feature requests are usually coming from the people using the database and then coming up with requests. So for example, if we are speaking about e-commerce websites, if you remember, if you're buying a laptop, you remember that you on the left side of the screen, you usually have configurator that is used to filter out laptops. So you can say, okay, give me all laptops with 15-inch screen and with 8 gigabits of RAM. So for example, RavenDB supports something like that on a database level. So what I'm doing here, I'm using RavenDB to generate facets. That's the name of this feature. I'm creating facets here, which are displaying number of the orders with the total value under 500 orders. So I have 193 orders between 500 and 1,000, etc., etc. And what is very interesting is that all these features can be applied in orthogonal manner. So you can combine various features and come up with various innovative applications of your database.
So, Dejan, I have some questions. And the first one is there RavenDB have a store for additional codes? Because you showed us that we can add additional codes in C# or JavaScript, but there is a store where someone else can go there and grab some codes from there and add here in RavenDB Studio, or if the developer is free to code some codes here.
So usual development cycle of your developers would be to inherit abstract class like this. So this is example of C# definition of this very index. So you go, you create a new class that represents this index, you inherit the abstract class, and you supply your code here. And as you can see, I also have additional sources here as well. So all of this is defined in your editor, and you commit it to Git. So this is versioned, and then you can train this index on your own machine, export it, deploy it to your production machine. So complete code is scriptable like this, as you can see.
Okay, and the other one is about the test. How developers can test the additional code before or after this code is stored, be stored in the RavenDB. And imagine you that I'm coding some sentiment analyzer or code analyzer, and I upload this code to RavenDB. So how can I guarantee to my end user that the code will deliver properly the result if without this code broke?
Okay, so you can imagine that no one writes working code from the first try, or maybe just people using Idris, which is completely like where you write formal proofs of your program. So in this case of, for example, tweets sentiment analysis, it also took me some time to write this code. And the thing is this, if you try to write code in high quality manner, you will divide your application into two layers. So one layer is so-called pure methods. And this is term coming from functional programming. Pure methods do not interact with the environment. Pure methods are receiving all of their input parameters from these parameters on the methods. So in this case, I'm using sentiment analysis .analyze, which is this method. So if I'm following rules of good, clean programming, I will write this method to be clean method, to be pure method. Pure methods do not interact with the environment. Pure methods only depend on the input parameters. This way, if you write methods as pure methods, and then you write unit tests for these pure methods, you will be able to test and verify correctness of your methods with high certainty, because you know that your method only depends on the input parameters like this one. So there,
go ahead.
So your method, in this case, analyze method, it is not interacting with the environment. And when you test it on your machine, since this method is not interacting with the environment, you are pretty sure that you will get the same result when you move this code from your machine into RavenDB. So that would be like general approach, not just with additional sources with RavenDB. This is essentially good programming. So you lower number of dependencies for your methods, and you make your methods affected only by the input parameters. So your methods will receive input parameters, do some calculations, do some computations which are not interacting with the environment, whatever environment may be, and then they will return results. So your unit test will be quite simple. If I have this text for the input, expected output is this.
Sure. It is one of the paradigm that came from functional programming, right? And
yes,
as you said, we can extract or grab some part of this code from the RavenDB Studio and apply some unit tests outside from the RavenDB, right?
Yes.
We can't test this part of code inside of RavenDB. We must have to guarantee this test outside from RavenDB before we send this code to them. Right?
Exactly.
Okay.
So
okay.
you will develop a class like this with the method. You will write your unit test to verify the expected behavior. Or, for example, you will verify how good your model is, because when you do machine learning, you have training data set, and then you have verification data set, where you prepare some inputs and you expect something to be detected according to your expectations. After you verify your code like that, method like this one, then you will create RavenDB index as a class that's inheriting abstract class, and you can supply your code here. And this goes into Git. It's completely versionable, and then you can choose whether you want to whether you want to deploy definition of this index ahead of time or along with your application.
Okay. And 31 question is about RavenDB executes ML.NET code inside of him, right? Awesome. But does RavenDB able to look up these packages in a private repo like ProGet or Artifactory or MyGet, for example?
Yes. So you can supply, as you can see here, you have a little switch here. So default package source is the NuGet. But if you have MyGet or any other source, you simply switch this and you supply package source URL.
Okay. What if happens if this private repo needs the user and password? Can we configure something like that in RavenDB?
I would have to check that to be completely honest. I did not try it.
But if it is a public repository, package repository, is completely possible to configure it there, right?
Yes.
Okay.
Yes.
It's no problem.
Okay. So this was introduced in 5.1. As people use it more and more, I'm pretty sure that they will discover additional scenarios, and hibernating rhinos will expand functionality to support these additional features that people are requesting. So if you look historically, lots of feature requests are coming from the field, from actual use cases where people are trying to use RavenDB in very innovative manners, and they are requesting new features.
Okay, Dejan. We don't have any questions. I think so that we were very assertive in our session. So thank you so much for sharing your knowledge in specifically talking about the machine learning in RavenDB. It's awesome to see how RavenDB is evolving so fast in a couple of years, from a couple of years until here. And yeah, feel free to bring to us some new features if you want. And yeah, thank you so much. So for the people that are in the chat, thank you so much. If you don't like this video, please like this video and share in your social medias, and feel free to follow us in this channel, YouTube channel, right? Thank you so much. See you in the next video here in this channel. Bye.